Imagine you're flipping a coin, but each flip gets a weight AI, and you add them up with random signs. That's a Rademacher sum. Everyone knows the usual rule: Kinchin's inequality tells you moments scale like a Gaussian. But here's the twist. The paper asks a sharper question. If we already know how far the fourth moment is from Gaussian, how large can the higher moments still be? They introduce a parameter Q, built from the fourth cumulant. Translation: Q measures the fourth moment defect from Gaussianity, and it also measures concentration of coefficients. If your vector looks like one active coordinate, Q is large. If it's flat across many coordinates, Q is small. So Q is like an effective number of participating variables, not just randomness, but geometry. Now, think of Q as a dimmer switch for how non-Gaussian your sum is. Turn it one way, and your distribution has sharper peaks. Turn it the other way, and it smooths out toward Gaussian behavior. The authors then prove a whole stability story. First, they build a sharp moment envelope, then combine it with a separate argument below a convexity threshold. The result gives a Gaussian stability inequality for the full range p at least 4. That means, for every exponent p, the best possible growth of the pth moment is pinned down by this fourth-order mass. But the story doesn't stop there. The same fourth moment framework determines the sharp finite-dimensional LP over L4 ratio. For p at least 5, the extremizer is the flat coefficient vector, so the most spread-out geometry wins. They even settle conjectures from Jakimiuk and from Boronsky, Murawski, Nayar, and Oleshkovic, and they prove Jakimiuk's quadratic stability at p equals 3. Why should you care? Because this coefficient-sensitive tail behavior plugs into random projections and signed errors, where sparsity and effective dimension matter. If you want the key idea you can reuse, it's this. Track the fourth-order geometry, and higher moments follow. Click like, subscribe, and drop a comment. What moment do you think should control the next breakthrough?